My name is Furkan. I work at Autodesk and I've been working there for 5 years. I've worked with QtQML for about 8 in total. And over the last 5 years, I've been working on a project that the product that I'm working on is Alias, which is a surface modeling CAD tool that is 35 years old. And it's been using an internal homegrown UI library. And for the last 5 years, we worked on replacing that with something more modern. We chose QtQML for that purpose. And this is going to be, this talk and the next one is going to be about my experience building that, especially with other developers who have never used the declarative language before. Since we started using QML, it's like, I think it's the best declarative best declarative language out there. So this is going to be my experience about that, where some tips and tricks about how to think about declarative programming, how to get into it, or even how to make your C++ code more declarative when you're developing. Before we get started, has anybody seen The Office here in the crowd? Oh my God, that's awesome. This is going to work better. So I think this is a great example of declarative programming. It's Michael Scott just naively declaring that he's declaring bankruptcy, right? And if you remember this scene, 3 seconds after this, Oscar comes in and it says, that's not how it works. You know, it's not that simple. So in declarative language, you essentially just declare an outcome. The outcome that Michael Scott wants to declare is that he's now bankrupt. But Oscar knows that underneath all that, it doesn't work that way. There's a lot more steps that you need to take. You have to, I think there were about 12, 13 steps here. I had to cut it down to something that you see on the slide. So yeah, the Valid Financial Association, credit counseling, and very many other steps, and then there's counseling post-bankruptcy. There's a lot of things that you need to do. But this goes into how the number of steps that you take underneath does not really matter for a declarative approach when you want to declare something. And it's essentially, declarative approach operates at a higher abstraction level than the imperative approach, because you're just looking at the outcome and not worrying about what's happening underneath at all. And in its essence, declarative programming is easy to understand and especially talk about it with other people, because you won't be going through a number of steps to explain something. You'll just say, let's say you're developing something with QML, and you're just like, I have a button. It's supposed to be green when you're hovering over it, and you just put a ternary operator and that's it. But you don't need to show them all the ifs and elses and getting the hovered state and all that. But with the imperative style, you will have a lot more control over it, because what if there's some other things that you need to do underneath, or there's some other steps that needs to go into it, or maybe you need to be close to the metal for some like embedded use cases, you need to do some additional processing there. That gives you more power, but with more power comes responsibility, which you need to have, but we can't be relying on that when we're operating at a higher level. So with the declarative style, that we give up some of that power. And this quote from Tim Berners-Lee demonstrates that. He says that in the 60s, 70s, there was a lot of effort to make the most powerful language, right? You need to be going faster and then doing more things, because resources were a lot constrained back then. But it says, in this day and age, maybe you don't need to be thinking about that anymore. Maybe what you need to think about is giving up control and power so that you can think more clearly about the problems that you're solving. And in the domain of especially UI development, I think declarative approach is more in line with the line of thinking that we have about developing GUIs or UIs than the imperative approach. This is especially true if you're a designer, for example. When you're getting into it, you want to do something, you don't think in terms of steps. You think in terms of, like I said, I have a button that needs to be red when I'm hovering over it, or green when I'm hovering over it. Oh, there was supposed to be another one over there. Well, there was another quote there. I don't know why it's not showing up right now. But that one is from, I always have trouble pronouncing his name. I think he's a Polish, Erkard Tyszarska. Does anybody know him? He's the go-to statement considered harmful guy. So in that, I don't know if you read that whole thing, but I found the title of that is the thing that people most talked about. But one line in that article I think is the most profound for me, where he talks about how our mental faculties for understanding things growing in time and changing dynamically is not yet developed to a place where we can reason with them efficiently and in a more powerful way. What he says is that our minds are better at is understanding static relationships. And with declarative approach, you essentially have that static relationship because you don't need even your eyes don't go all the way top to bottom. You don't think about all the steps. You just look at it. And especially if you have like good componentized code in your code base, then it'll be much easier to just look at a code and understand what it's going to show. Lucas was actually telling me that today. It's like when I look at the QML code, I can clearly see what the outcome of that will be. And this is a very simple, I even removed all the std stud namespaces, but in this case, you just have a list of numbers. You just want to double them, each one of them you want to double multiply them by 2. And this is the imperative approach, where you go from initializing the numbers, the vector, and doing the for loop, and then going through each of them. It's a simple case, a very simple case, but even in this 3-4 lines of code, there's multiple state changes happening. We initialize the I in the beginning, and then that state changes with each, because each of those are control block statements, so all of that executes code and it changes the state that you're in. And this is another good code that I like. You've probably heard of it. All problems can be solved by more abstractions, but not the problem of too many abstractions. And like I mentioned before, in a way, declarative style is another abstraction layer on top of the imperative one that you're doing. So this is the most imperative one that we've seen before. Interesting. I think the clicks that I have here are not working. Maybe that's why. Yeah. So would you mind doing the arrow here for me? Thank you. Okay. This is a tool called SlideDiv. It's awesome. Don't be fooled by this. It's just this is not working. So this is the most imperative style that we're seeing. And in the next one, we have another abstraction layer, which was introduced in C++ 11, where you can do the range-based loops. Right now, I don't have to worry about the index or anything else. It's just numbers that I'm dealing with. And in the next one, it's a more functional style of programming, which is a subset of declarative programming. In this one, there's a bit more happening here because with the iterators, it's not really that pleasant to use, but you still take away some of that complexity, quote unquote, that we had with going over them. Now I just have get all the numbers and multiply them by 2. And in the last one, this is the ranges version to C++ 11. And in this one, this even probably reminds you of Bash. You're used to that. You just pipe things through, and then that's make or Bash probably are among the earliest declarative languages out there. Okay, this was the code that we're missing. Yes, I'll do this part of it. Okay. So this was in the slide that we missed, the click one. I think this is a profound statement from that article. So we need to be thinking about static relationships instead of dynamic relationships, because things that are going over time are hard to grasp. But if we establish something and then it stays that way, it's much easier for us to deal with. And this is, I'm sure the embedded folks know about this, but the signal to noise ratio. And this one, the principle is to make sure that you get a lot more valuable and precise information than background noise out there so that you can make better decisions based on that information. And I think relying on imperative style in certain cases can give you a lot more noise than signal, especially like if you have people in your team who are not as experienced in that style or not as experienced in the language that you're using. This is going to be a lot of noise for somebody who's just starting. But this is going to be a little bit better. That's why I have the question mark there, depending on what you've been exposed to. But with a little bit of knowledge and experience in the declarative style, you'll find that this is much easier to deal with, especially in complex cases where you're dealing with a lot of state changes. This is to get everybody, a good Lucas. Can you tell me what this code produces in 3 seconds?
Yes.
Yes? No? What is it? Okay. Failed. It's a very simple case actually. It's not because Lucas that's what everybody would have done in this case. Even I wrote that, but I still don't know. I can't look at it and say like, yes, this is what it's producing. It's hard to see. Yeah, but you look at it and you have to think about it, right? You have to, it's a process. That's a good one. So we'll look at the next one. You look at this in 3 seconds, you can tell me that there's a button and a label and you increment things. And that's essentially what it is. There's nothing else to it. So I have some rules of thumbs when dealing with declarative style. This is especially true for QML, but again, you can, for some language, for C++, for example, with some syntactic sugar, you can do declarative style programming, especially with ranges or some of the algorithms library that we have. But if you're revealing intention in your code, thinking in terms of byte relationship static, especially static relationships, and your eyes, this is kind of a back of a napkin thing that I have. If your eyes are moving up and down instead of left and right, you're probably doing imperative style. And more bindings and less signals, because signals are like the go-tos of declarative programming in QML at least. And the other one is, think of in terms of values, not mechanics. The value is changing instead of how that value is changing. This is a simple example because this is one of the things that still happen in our code base coming from an imperative style. When we're getting something, we think that, oh, it's a const operation. I'm just going to get a number from this class. But getting something is itself essentially is not an immutable operation. It's a mutable operation because you get money from an ATM machine. You have the unfortunate side effect of having less money in your account, right? Or you get married, you're not single anymore. It's a state change. You get to some other state. But if you change it to just hour, then if you just money or you're just married, it's much better. It reveals more intention for your code. But there's a lot more cases for this that I won't be able to get into in a 15-minute talk. Binding relationships part of it. Is this a declarative code? Anybody saying yes? Raise your hand. No. It's not, because you're in the scope of an imperative statement in the hover change signal, and then that's doing something. But even if, when you look at that code, once you read it in your mind, that state will change, and then you want that state, that relationship will not stay in your mind. But when you look at the code at the bottom, once you read that, that relationship will stay stuck in your head, so that when you see the hovered state changing or the hovered property in someplace else, you're like, oh, there was a rectangle that was changing its color when the hovered state changes. This is an example for eyes top to bottom, so eyes left to right instead of top to bottom. So this is when you're reading the onCompleted signal handler here, we're going from top to bottom, and as we're going, in our minds, most of us probably do it, we're executing the code in our minds when we're reading, right? When we execute this code, we'll see that the text changed, but then what stays in our mind is the mechanics of the text changing and not the relationship that text has to the index and the name itself. So in order for us to understand that this is changing in time because there's going to be multiple indexes, that's going to take up extra effort when understanding. But in this case, we're still doing the same thing essentially, but looking at it, you form that relationship. When I look at it, you don't even think much about it. It's just when you imagine it, that binding, you evaluate the binding in your mind when you're thinking about it. There's last bit are the considerations when you want to decide imperative versus declarative style. First is readability and maintainability. In most cases, declarative style of coding is going to be more readable and maintainable than imperative style. This is something that you've seen like in the simple for ranges that you'll see, or when you're filtering a lot of data, that's a good case. Instead of writing 3 for loops, you can just maybe have a reduce call or accumulate call or a transform call, and then that will make it easier to understand. But this relies on the assumption that the developers that you're working with are familiar with the algorithms library in C++ or whatever language that you're using. We'll see different examples with other languages as well. Oh, can you, for me, thank you. So this is in JavaScript, for example, you you do a lot of big brain processing to understand this, but if you look at a more functional declarative version of it, it's a bit easier to understand, provided that you're familiar with the filter and the map functions. The other one is complexity of logic. In this case, similar to the loops and the while loops, this will be if you end up in a situation where you're seeing a lot of logic changes in your code, that's when it's also good to switch to a declarative style. But that one, because with those logics you can establish relationships, static relationships that are not changing, or even if you have state changes, you can establish those, and then when you look at the code, it'll be easier to understand. When you look for these examples, there's a lot of it related to filtering and mapping and all that stuff. Can you press one more? And in this case, like we have the accumulate, filter, transform calls, provided if you're familiar with these, and the pipe operator, which most of us are familiar with, it relies on some of the concepts that you've like burned into your brain. It'll be easier to understand. This one is QML, for example, or SQL, or I'm sure we have many other examples, or maybe you even implemented something in your code base when you were trying to solve a situation. And it'll be best suited for especially UI or data representation or state representation purposes. Even XML, for example, is a declarative style, or HTML is a declarative style. And I have a few examples of this that are building the same UI from before with QML, but in different languages. So this is the imperative version of Swift. And you look at it, there's a lot of happening here. You have to read a lot. Next one is this Swift UI, which is a more declarative version of it. Like it's much simpler, it's much easier to understand, even though all of the mechanics of the first code sample that we saw is still happening underneath. Another one is with Kotlin, although I must say the declarative version of it is not that pretty because it's XML, but it's essentially doing the same thing. And if you look at it, like even between the different libraries, they're using similar concepts like layouts and boxes and buttons. All of it are similar, but the mechanics of it get complicated because that's the complication that you don't want to. You have more important things to do in your day-to-day job than worrying about, this sequence of events that are happening. XML, I had to cut a lot of it out because it doesn't fit into one slide and I didn't want to scroll. And this is the last QWidget version that we saw from before, and the QML version is much simpler. The last one is the state management, and this is especially true if you're dealing with like state machines, or you have cases where you go from one screen to another, or some state change. I'm sure in embedded development you have this a lot. Maybe some network information came in or some data changed, and you can get into a lot of different cases by doing this instead of worrying about all the ifs and elses and reading like 500 lines of code, where you can just have maybe 100 or 50 lines of code to understand these properly. So if you have a lot of those, even switching to something like JSON, which in our product we did, switching to something or initially actually we were using Scheme, which is also somewhat of a declarative language. So that, even in the 80s, made sense for people. And if you know a little bit about history of GUIs, from anybody familiar with Mother of All Demos from the 60s? I highly recommend, if you don't know about it, I highly recommend checking it out. It's an hour-and-a-half demo from, I think, Stanford University from the 60s. And most of the modern UI functionalities, like what you get kind of editors, menus, buttons, even video conferencing are all demoed in real time in that conference, and it was a countrywide event where it got a lot of attention during that time. And after that, when these UI GUI desktop development was getting more commonplace, you probably heard of Smalltalk, which was invented for the purpose of creating UIs. It wasn't just another, they weren't just like, okay, let's create another object-oriented language. So like, no, we are doing a lot more GUI now than before. Maybe we need to change the way that we're thinking about it so that things are a lot simpler. I think our job is to learn, so we should just be fine with the learning curve in general, but it can take a bit of more time because it's a paradigm shift in our minds from going number of steps to just creating relationships in our minds, which in our team also, for me, I learned it so many years ago that's probably like the survivor's bias. I don't remember how long it took for me to learn. It's like learning pointers. Now it makes sense to me, but when I was first learning pointers, I couldn't understand it for the life of me. But once you get over that stage, it'll be much simpler to, again, reason with these things, but during that time, it'll make a lot of sense for somebody in your team who's knowledgeable to provide more support, more patience for the other people, and not fix it because they didn't do it right way, but show them how to do it so that things can get better over time. Thank you so much. There's a lot to talk about in declarative programming. Hopefully, one day there's going to be another Qt conference, Qt Greece meetup conference, and I'll have maybe 40 minutes for this, and we'll get into more. Thank you very much for listening.